In this video, I'd like to walk you through how to solve a quadratic inequality like the example you see here without the assistance of a graphing calculator. Here's the example. We've got x minus 2 times x plus 5. That's a quadratic in factored form. And notice that the inequality is set to 0. So this is really the problem handed to us on a silver platter. Other examples might have this written out in expanded form like x squared plus 3x minus 10 greater than 0. And an even more challenging stuff, well, not really challenging, but more intense because we've got more steps to do. It might be set to greater than 7 or 8 or -2 or whatever, but not 0. The first step is to get this thing set to 0, just like solving a quadratic equation. And then the next step is to factor it. Once it's factored, here's what we're going to do. In this process, once we embark on this, you might think, oh, I remember doing that at some point. But it's one of those processes that we don't really use that often. And so because it's not used that often, it might be something that you just forgot to do this, right? So here it is. We set each factor to 0 and solve. You're probably used to that because if this were an equation, if it was a quadratic equation, that would have probably come really naturally to you. So we set each factor to 0 because it's already set to 0 here. We set each of the two factors to 0. And when you think about that, maybe you've done this blindly for years. You remember doing this back in Algebra 1, or maybe even in pre-algebra. And you've just gotten used to doing that. When you see the x minus 2 as a factor, you just jump to x equals 2. Well, think about what you're doing there. What is it we're doing? We're saying that if this thing is equal to 0, then it must be true that either this factor or this factor is 0. So if we had this written as an equation, x minus 2 times x plus 5 equals 0, then we would know that either x minus 2 is 0, meaning that x is equal to 2, or x plus 5 is equal to 0, meaning x equals -5. It's okay if you don't show that step at this point. If you can jump straight from x minus 2 to x equals 2, and x plus 5 jump straight to x equals -5, that's okay, but make sure you understand what you're doing there. What we're finding here, because this is an inequality, not an equation, what we're finding is the critical numbers. So the 2 and the -5 are the critical numbers. I'm going to mark those on a number line, and I'm going to put them in order on the number line. And because we have a greater than, not an or equal to, it doesn't say greater or equal like this, right? Because of that, I'm going to write this as a broken line. So I'm going to draw a broken line. And let me say, the process I'm using, it's not a set process. There's some math concepts that there's really one very well received way of doing the problem. For this type of problem, there's multiple ways you could do this. I'm just showing you the way that I have found works really well, but I'll tell you what, if you do it like this every time, you're going to get it right every time. So if you don't already have a process, then maybe try this. What I'm doing here is I'm writing our quadratic, our x minus 2 times x plus 5 in for each of these intervals. What I've done by writing in those critical numbers on the number line is I've divided the number line into 3 segments. So here's what's true. With an inequality, a quadratic, or really any polynomial inequality, what's going to be true is that if I take a test number somewhere on this interval, so I'm going to test, let's say, a -10. -10 is on this interval that goes from -infinity to negative 5, right? This interval from negative infinity up to negative 5, negative 10 is a member of that interval. So I'm going to use negative 10 as a test number here. On this interval from negative 5 to 2, I'm going to take the easy 0. Wherever 0 fits in, we want to use 0. It's because it's easy, right? And then pick any number on this interval from 2 to infinity. Well, I'm going to pick a 100. You might think, well, why do you want to bother with such a big number? You'll see in just a minute why that really big number is going to be really helpful. What I'm going to do next is I'm going to go into the inequality, and I'm going to insert my test value. Where did the test value, this green negative 10, come from? I just picked any number I wanted on the interval from negative infinity to negative 5. Where did negative 5 come from? That was our critical number that made our x plus 5 equal to 0. So it would make this quadratic equal to 0. And what I'm looking for here is simply whether I get a positive or negative. Now, just to be clear, I'm going to write down the value, but I don't have to be concerned with the 12. I really am just concerned with the fact that negative 10 minus 2 is going to be a negative. And negative 10 plus 5 is going to be a negative. I'm writing the exact numbers down just so you can follow me here. But notice that really all I'm concerned with is that they're both negative. And what happens if I multiply a negative times a negative? I get a positive. Now, is a positive value greater than 0? Yes, it is. So here we get part of the interval that's included. So anything from negative infinity up to negative 5, but not including negative 5, would make this inequality true. Let's look at the next segment with the critical number of 0. We'd have 0 minus 2 is negative, 0 plus 5 is positive. When I multiply a negative times a positive, I get a negative. Is a negative greater than 0? No, we're not going to include that. And then, let me write that in. We'd get a no. And I could even put an X over it, right? And then when we move to the last critical number, well, not the critical number itself, but we move to the last segment that was divided up by the critical number. So from the critical number 2 up to infinity, on this interval, I picked a 100. Well, why did I pick such a big number? Because when I pick a really big number there, it becomes dead obvious whether it's positive or negative, right? Anything from 2 to infinity, that big number minus a little tiny 2, it's still going to be positive. Really big number plus 5, still going to be positive, right? And when I multiply a positive times a positive, I get a positive, and that looks like it's a yes. This is included in our solution. So when I go back to my number line and I look at this, I'd see that anything from, that highlighter was just too fat, and it made that negative 5 when I was trying to circle it look like I was coloring it in. Why am I circling it and not coloring it in? Because we have a greater than, not a greater than or equal. If it was equal, we'd actually color it in as well, right? But we're just concerned with the negative 5 being the end point, not included. But because we got a yes here, we're going to say that this negative infinity to negative 5 is included in the solution, and the interval from 2 to infinity is included in the solution. So if I were to write that solution out, I'd see that it's all the x's that are less than negative 5 or greater than 2. Both those sections, both those regions, both of those intervals are included. And now, speaking of interval, we were asked to write the answer in interval notation. So I could write that in interval notation by starting here with the negative infinity and saying we go from negative infinity up to negative 5. And then union, meaning or, anything that starts at 2 but doesn't include 2 and goes up to infinity. Could I encourage you to watch the next video if you want to see an example that goes a little further? So it would start with a quadratic like this. and then also it's a less than and it's a or equal to. I'm going to stop this video here, but you might find it helpful to watch that second video if you want to see that second example. If you do have questions about this example, though, I hope that you'll reach out to me and let me know.